going to look at some things with circles. I'm going to start with circumference. Think of circumference as the perimeter, distance around a circle. The ancient Greeks knew that there was a ratio between a circumference of a circle and that circle's diameter. And you've seen that ratio before. It's called pi. Pi is the ratio of circumference to diameter. Written in more modern notation, we say that circumference is equal to pi times the diameter of a circle. And because we know what a diameter is, we can also say the circumference is 2 pi r. So if we happen to know that diameter, we can find the circumference. If we know the distance around, then we can find the diameter or the radius. Pi is one of those mathematical constants that is called transcendental. It's a transcendental number. What that means is it's not a nice decimal that ends. It can't be written as a fraction of whole numbers. It goes on forever, never ends, and it also never repeats. It just continues on and on and on and on. Numbers like the square root of 2 have that same property, but they're a little different than pi. Square root of 2 is also what's called an algebraic number. Pi is not an algebraic number. And to understand what the difference between those means requires several more courses of theory to get into that. So let's just say that pi is somewhat of a unique number. It sort of transcends the traditional rules of mathematics. So, what is pi, approximately? For our purposes, 3.14 is good enough. If you are going to be an engineer in designing various things, you're going to need much more precision than that. You might take pi out to 6 or even 10 decimal places. If you are going to be some sort of astronomer or study the universe, study quantum physics, quantum mechanics, study things on a very, very small atomic scale, you may need pi out to 20 or so decimal places, because you need that level of precision, either to deal with the very, very large or the very, very, very small. So various branches of math have various uses of pi. And pi shows up in many, many unexpected places. It shows up in physics when you deal with what's called orbital mechanics, the way things move around, orbit, rotate, revolve around an object. It shows up in statistics. It shows up in various parts of number theory. It shows up in all kinds of different areas. So again, for our purposes, if we need to estimate it, we'll stick to 2 decimal places. 3.14 is fine. There will also be times, though, where we don't calculate a decimal value of pi and we just leave it as is. Here's the next part, and that's area of a circle. So let's just focus on this top one for a moment. If we take a circle and split it into 8 pieces, shade half of them, and then rearrange those pieces, we get this shape right here. It kind of sort of looks like a parallelogram. It's not really, because each of these slices has a little bit of curvature here, So it's not a nice straight line, but it kind of sort of looks like a parallelogram shape. We could say that its base is half of the distance around, half the circumference. We could say its height is the radius. And now if we take that same circle and cut it into smaller pieces, now we start to see more of the parallelogram shape. These are still little tiny curves here, but the curvature has been flattened out because we made the pieces very, very, very small. And this is sort of the process that was used to come up with the area of a circle. By making the pieces ever smaller and smaller and smaller and smaller and smaller, this gets straighter and straighter and straighter and straighter. It will never be perfectly straight, but it will get very, very, very close to it. So this base, again, is half the circumference. This height is equal to the radius. We know the area of a parallelogram is base times height. Base is 1/2 2 pi r. The height is r. Therefore, the area of a circle comes out to be, well, the 1/2 and the 2 knock each other out. We get pi times r. We get pi r squared. That is where the area of a circle comes from. There is a method, if I go back here for a moment, there is a method to determine how to get the circumference of a circle, but it's not very nice. It's very complex. It uses some very convoluted methods that the Greeks came up with, and would take me about an hour and a half or so to go through thoroughly and plainly, or in a way that would make sense. So oftentimes we just assume that this ratio exists. We skip the proof because it's not a nice method. If we had calculus techniques available, I could do it in 10 minutes, but then you wouldn't understand any of the calculus that goes behind it. So it's not worth it. Area of a circle, though, very, very slick. Again, it's kind of using a calculus concept called a limit, but it's very easy for us to see what's going on there. So circumference of a circle and area of a circle. Then we can look at parts of those concepts. So arc length. An arc, we know, is just some curved path on the circle. And in our circle unit, we looked at ways to measure this in degrees. Well, now we're going to look at an arc as a measure of distance. So if I have a radius and I have an angle, let's call the angle x, I have this S. S stands for arc length. There is a way to determine the length of this arc. So instead of going all the way around the circle, maybe we only want to go this distance. So how do we find that distance? Well, the distance is simply a fraction of the circumference. Since I'm using a fraction of the circumference, I need to know what fraction of the circle I have. I know that a central angle is equal to its arc in degrees. So in other words, if this is a 45-degree arc, this is a 45-degree angle. If this is a 90-degree arc, 90-degree angle, and so on. That's how we determine our fraction. Whatever angle this is will be this degree measure here. And we know how many degrees are in a circle. So if this is a 60-degree angle, I have 1/6 of the entire circle, which means that this arc would represent 1/6 of the entire circumference. If this is a 45-degree arc, this 45 over 360 represents 1/8 of the entire circle. So this would be 1/8 of the circumference, and so on and so on. So to find the length of that arc S, we simply take that fraction times our circumference. Whether it's 2 pi r or whether it's pi times diameter, that's the fraction we multiply by. And if we can find the fraction of a circumference, we can find the fraction of an area. So I will recreate that same arc. And I will create a sector. Think of a sector as this area. I think of it as a slice of pizza or a piece of cake. Here is the sector. Area that's shaded here. A sector is simply the area between two radii. Area between two radii. So there's my angle, x. Here's my radius. Sector is a fraction of the entire area. So again, it's simply that fraction of the circle times the entire area. If this is a 45-degree angle, this represents 1/8 of the circumference, and this represents 1/8 of the entire area. That relationship holds. If this arc is 1/4 of the entire circle, it will create a sector that is 1/4 of the entire area. Very, very nice relationships there. Example time. Find the circumference and the area to the nearest tenth. So, I have sort of circumference. Circumference is pi times diameter, or 2 pi r, depending on what we have. Here we have the diameter of the circle, 18 times pi, and it says round to the nearest tenth. So I will plug in 3.14 in place of pi, rounded to the nearest tenth, approximately 56.5. And let's put a unit on here. Let's make this inches. So this would be 56.5 inches. Circumference is not an area measure. It is a distance measure, so it does not get a square unit. Find the area. Pi times the radius. If the diameter is 18, the radius is 9. So this is 81 times pi, 81 times 3.14. And this will get the square inches unit since it's an area. Some calculators have a pi button, and if you use that, it's fine. It usually will give you answers that are very similar. So if I use the pi button instead of 3.14, I get the same answer for the first one, and I get a different answer for the second one. For the second one, I get 254.5 square inches. So sometimes the pi button gives you a slightly different answer. Doesn't mean it's wrong. It just means that the calculator, using the pi button, the calculator uses, I believe, 8 decimal place accuracy. It uses 8 places. So at least this particular one I'm holding uses 2, 4, 6. I stand corrected. It uses 9. This is a TI 30 that I'm using. This pi button uses 9 places of precision, which will give you a little more accurate answer than just using 3.14. Does not matter to me which one is used. Both answers would be acceptable. Let's take a look at the same problem from a different perspective. So find the circumference and area in terms of pi. So let me back up here. The previous problem said nearest tenth, so an approximation. In terms of pi is a much more accurate way of expressing these answers. Circumference, we know, is pi times diameter. Diameter is 18 times pi. Again, if I put inches there, 18 pi inches, that is what's called a mathematically exact answer. We're not approximating. We are not approximating. We are saying it's 18 pi inches. That is exact. It's like saying the square root of 2 instead of, it's about 1.41. The square root of 2 is precise. Pi is precise. Do the same thing with area. It's pi times the radius squared, 81 pi square inches. That's the exact value. So be comfortable expressing answers both ways. In terms of pi, leave pi alone in your answer. Approximation, that means you will plug in a value for pi and get something that's close to the true value. Let's one at a time. Find the length of the arc in terms of pi. Okay, we know that arc length is some fraction over 360 times circumference. So our fraction, 60 over 360. We have the radius of the circle. And now we just do some basic arithmetic. So we have 2 pi times 12 is 24 pi. Just treat pi like you would treat a variable when you're doing calculations. So 24 pi times 1/6. Our arc length is 4 pi. And again, if we used inches, this would be 4 pi inches. Arc length is like circumference. It's a measure of distance. Find the area of the sector in terms of pi. Again, we have fraction, pi, radius, squared. Radius squared is 144. Multiply by 1/6, we get 24 pi square units. Whatever our units is, it would be squared. So that is how we find circumference and area of circles, how we find arc lengths, and areas of sectors.